When I press this switch, this light should go off, this light should turn on, because our relay has a magnetic field created. Hey everybody, I'm Scott Meek, Training Manager at Diesel Training. In a previous Tech Tip video, I made a promise to you that if you came back to see us, I would show you how an automotive 5-pin relay works. So in today's lesson, we're going to cover that. Now, why is it so important that we understand how a relay functions in order to troubleshoot it? Well, when I was in the field, a question that I got often whenever there was a relay in a circuit or a schematic was, hey, Scott, how do I troubleshoot this? How does this function? So I think we need to take the time to just give you a clear understanding of how our relay functions, and that way we can accurately troubleshoot it. Now, don't overthink relays. There's no magic here. Basically what you have is an electromagnetic switch, okay? There's no magic. It's a very simple process. Now, on a standard 5-pin automotive relay, we have 5 pins. So to get started, I want to spend a little bit of time explaining what each one of these pins do, what their name is, and what would be expected at that pin. So I've drawn a diagram here, a few different options to help explain this. But we're going to start up here on the top. Now, if you have a 5-pin automotive relay, you have 5 pins, and those pin numbers will generally always be the same. Now, remember, there's always exceptions to the rule, but if you look at the bottom of a relay, if you actually unplug it and you look at the pin side or the terminal side of the relay, you'll actually see that those are labeled, okay? And if we come over here and look, you'll see that one of those pins will be labeled 30. Now, pin 30 is referred to as common, okay? Now, the next pin that we'll have will be 87A. 87A is a normally closed pin. What this means is the switch will be normally closed. So if there's no power or ground applied to the circuit, pin 30 and pin 87A will have contact, okay? The next pin that we have to talk about is 87. Pin 87 is considered normally open, which means if there is no human interaction and this relay is at rest with no current moving through it, then 87 will not have any contact with pin 30. Now, I called pin 30 common. Here's an easy way to look at this. What do pin 87A and pin 87 have in common? Pin 30. Now, it's also important that we look at a relay in 2 different pieces. We have the switch side, which is 30, 87A, and 87. And then we have the coil side or the control side. The coil or the control will be pins 85 and 86. And this will be standard. So if you go to an auto parts store or if you're just working on a standard vehicle and you pull out a 5-pin automotive relay, you will see pins 30, 87A, 87, 85, and 86. Pin 85 and 86 is responsible for creating a magnetic field so we can attract this little switch so it can move from pin 87A to pin 87. So when we think about pin 30, think about a gate, right, on a fence. You have the gate is closed, and then when you unlatch the gate to open the gate, one side of the gate stays mounted to the fence post, right? So that gate can move back and forth. It pivots. That's the same concept that's happening here. Pin 30 is a switch, and whenever we apply current to the coil, we'll create a magnetic field that will attract this switch, and it will pivot from 87A to 87, always being connected to 30, okay? Now, I've got to go a little bit deeper in explaining some of these things, and of course, there'll be other lessons that can help with this. But how do we create that magnetic field with that coil? Well, remember, anytime current moves through a circuit, a magnetic field is created. And if we use a coil, we can increase that magnetic field strong enough that we can physically move objects. So in this case, all we would need to do to energize this coil would be to simply provide a power and a ground source so current is moving through the coil. Now, as a standard, and again, exceptions to the rule, but as a standard, pin 85 on an automotive relay would be ground. Pin 86 on a standard relay would be power or voltage. So if I applied a 12 volt source to pin 86 and I applied a ground to 85, now I have current flow. Current moves through the coil, the magnetic field is created, then this switch will move from 87A to 87, simply pivoting as such. Now, underneath this, I just have a short little diagram of what it would look like if you were looking at the relay pin terminals. If I was holding a relay and looking at it and reading the numbers, I have the diagram here. So, pin 87A is going to be located in the center of the relay. Pin 87 will be located above it. Pin 30 will be turned in opposite direction on the opposite point of 87. And then on the sides, you will have pin terminals 86 and 85. So what I've done is I've taken the liberty of drawing a really simple schematic here that can kind of give you an indication of how this is working, because right now I'm just talking about it. Now I've got to show you. So if we move over here to the schematic, what you'll notice is this. We have a voltage source, okay? We have our battery. Now, on one side of our battery is positive, the other side of our battery is negative. So in this case, I've got a 12 volt source, 12 volts on one side, 0 volt on the other. Remember, ground is 0 volt, okay? Now, if my voltage is coming from the battery, I'm going to a fuse, and then you'll notice I've got a little junction here. One side of my junction is going to go to a momentary switch. When you think of a momentary switch, think of something that you have to push, and then when you let go, it releases itself automatically. So the first thing that comes to my mind is like a horn button. When I press the horn, I push the switch in, the horn honks. As soon as I let go, the horn button will release automatically, the horn will quit honking. So that's just a momentary switch. Now, when I'm going to this junction, one side splits to pin 86. The other side is going to pin 30. Now, what I'm trying to show you here is that pin 30 has constant power. And then we also have constant power coming to one side of the momentary switch, but we have no voltage going to the other side. So voltage is applied, it goes to pin 30. It travels through the switch in the relay, which is normally closed, which means if nobody's doing anything, if there's no human interaction, then that voltage is leaving pin 30 and going to pin 87A, which is then going to lamp A. Now, on the other side of my battery, I have my negative side. We talk about this as being ground in our industry, but it's negative. We're coming off the negative side of the battery. Notice that I'm going to pin 85 of the relay, but I'm also sharing that ground with lamp B and lamp A. So right now, the way that this schematic is drawn, with no human intervention, my voltage is leaving the battery, traveling to pin 30, through the relay, to pin 87A because it's normally closed, and then going to my light. My ground does not have any switches, so it is a direct line, which means I have ground all the time. So right now, lamp A is technically burning. It is lit up. Well, that's a problem because lamp A is lit up, but what about lamp B? How do I get lamp B to light up? Well, what I have to do is energize the coil of my relay. And to do so, remember, we need to apply voltage and ground, or positive and negative, to this coil in order for current to flow so we can create that magnetic field. So, right now, lamp A is lit, but I want lamp A to turn off, and I want lamp B to turn on simultaneously at the same time. So, if I were to push this momentary switch, this switch would now be closed, which means I'm making contact on both sides of this connection. As soon as I do that, the positive voltage that's coming from the battery to pin 30, it's still there. It hasn't changed. It's going to continue to be there because that's a direct link to my voltage source. But as soon as I press this momentary switch down to create a connection between the contacts, now I have voltage moving through that contact to pin 86. Well, now that I have voltage on pin 86 and I have a constant ground, now current is moving through this coil, which means a magnetic field is being created. Once that magnetic field is created, that switch that's connecting 30 to 87A, it's now going to pivot on that post, and we are now going to connect 30 to 87. And basically what that means is I have broken the connection between 30 and 87A, and now sent that connection, that voltage source, from 30 to 87. Well, there's two things that are going to come of that. Number one, lamp A will quit burning. Lamp A now will turn off. Why will lamp A turn off? Well, remember, for a lamp to work, you have to have a positive source and a negative source. We've still got our ground in the circuit, but we've lost our positive feed because that switch has moved. This is now an open connection. Now that we've done that, voltage travels from the battery through the fuse, still going to pin 30, but now it's traveling to pin 87, which is traveling to the lamp. Lamp A turns off, lamp B now turns on. It's that simple. There's no magic here. As soon as I let go of this switch, this momentary switch, the switch is open. So my contact is now open, which means I have an open circuit. And once that happens, I no longer have current moving through the coil because I've broken the circuit. I have an open circuit. Once I've broken that contact, current no longer flows through the coil. The magnetic field dies. And now, once that magnetic field dies, there's no electromagnetic force that's attracting this switch. So this switch under spring tension will go back to its original connection, its normally closed connection, because there's no human intervention. And now my voltage will travel through 30 to 87. Lamp B will turn off. Lamp A will turn back on. It's that simple. So there's really two main reasons that you're going to see a relay in a circuit. One reason is because of what you've seen on the board here today. We want to turn one thing on. At the same time, we turn something else off with only one action. Another reason would be we're going to use a small amount of current, small gauge wire, small amperage draw, to control a larger circuit with more amperage draw with larger wires. So little current controls big current. A couple examples there. Now, the next thing that I want to do is I want to use a little kit that we have that's going to let me show you when I wire an automotive relay up how that relay functions. So I'm going to show you the momentary switch. I'm going to show you the lamps. I'm going to show you the relay. We're going to take this very schematic here and we're going to put it on a table for you to see yourself. So now what we're going to do is I'm going to take this really neat little demonstration tool and I'm going to slowly walk you through how we're wiring this relay up, because I believe that's really going to help you understand how a relay functions. Now, just like on our board, we have two lamps, we have our voltage source, we have our relay, and we have our momentary switch. Now, when you're wiring this circuit up, don't overcomplicate it. Keep things simple. I know you hear that often, but there's a reason for that. So, what I typically do is start by saying, okay, what do I want to turn on first? What's supposed to be turned on without human interaction? Well, we're going to say lamp A, right? Just like our description in the back. Now, what does lamp A need to function? Lamp A, or a lamp, will need a voltage source and a ground source, a positive and a negative. So I'm going to start by doing that. But here's the cool part. Lamp B, it needs the same thing, right? So what I'll do is I'll take this little contact and I'm going to jump lamp A to lamp B. Now what I'm doing here is I'm giving a path to ground is what I'm doing. A path to the negative side of the battery. So since both of these lamps need ground, both of them can share ground, I'm going to connect the grounds to the two lamps, and then I'm going to connect that ground link to the negative side of my battery, like so. So now we know that both of our lamps have a negative source, or a ground as we call it in our industry. Now I need to get them to turn on, so I have to apply a voltage. Now this is where the relay comes in. Because remember, I want lamp A to burn all the time until I press the switch. Then I want lamp A to go off, and I want lamp B to turn on. So I need to provide voltage sources here. Now to do that, since those are going to be controlled, I'm going to use a relay. So the first thing that I'll do is I will connect lamp A to pin 87A of the relay. Why is that? Remember, 87A is normally closed, which means without me pressing this switch, lamp A will have power on it all the time. But only until we press the switch will it have power. So now, in order to get power to 87A, it's going through a contact inside the relay, and it's the normally closed pin, so that means 30 and 87A are currently connected without any human interference. So I need to supply voltage from my voltage source to pin 30. Once I do that, since I have a direct connection, that voltage will then go through the contact from pin 30 to pin 87A, which means this light should turn on. So now I'm going to apply voltage to pin 30. And now you notice our light's burning because 30 and 87A are normally closed, are connected without any interference. Now, in order to get this light to turn off and this light to turn on, I need to supply a voltage source to this light. Now remember, they're both sharing the same ground, so switching the voltage is how we're going to control this light. So, if I have lamp A connected to 87A, well, that means I need to connect lamp B to 87. So, I'll take a little contact and connect it like so. Now, the last step is the control circuit. Remember, in order for our voltage to move from pin 87A to pin 87, we have to create a magnetic field that's going to physically move that internal switch of that relay. So that leaves us with pins 85 and 86. Now again, industry standard says that 85 is typically ground and pin 86 is typically voltage supply. There are exceptions to that rule, such as if you had an internal diode inside of that relay, a flyback diode, to protect sensitive electronics. Then you need to put ground on 85 and power on 86. But if you're using just a standard automotive relay with no internal diodes, you can technically put power or ground on 85 and 86. It won't hurt anything because you're just moving current. So let's go by the standard and say we're going to supply ground to 85. So I'm going to take a wire. I'm going to go from my ground source or my negative source, and I'm going to go to 85. So now I have ground coming from the battery to the lamps, sharing that ground with 85. Now the last piece of the puzzle is going to be controlling that circuit. How do we control that coil? Well, we add a switch. So I'm going to take a momentary switch and I'm going to supply a voltage source to that momentary switch. Now remember, your switch, both sides of the switch will be on the same side of the circuit. So in this case, it's the voltage side of the circuit. So pin 86 will be connected to one side of the momentary switch. And remember, we're providing voltage on 86 because we have ground on 85. And then I'm going to take the other side of my switch and I'm going to connect that to a voltage source, which in this case, I have a voltage source coming from the battery to pin 30, so I can use that voltage source. Now, when I press this switch, this light should go off, this light should turn on, because our relay has a magnetic field created. The internal switch will move, transferring power from 30 to 87A. to 30 to 87. As soon as I let go of the switch, the spring tension of the relay will automatically make that connection go from 87 and 30 to switch to 87A and 30. And there you have it. It's a very simple process. Don't overthink relays. Keep it as simple as possible. Keep the relay in two pieces. When you're troubleshooting a relay, remember the switch is 30, 87A, and 87. The control, or the coil side, is 85 and 86. We control the relay with the coil. When we create the magnetic field, the physical switch that's always connected to 30 because it's the common will go from 87A to 87. I hope you found this tech tip helpful. If you did, please leave us a comment. Click the like button. And if you want to stay tuned for some future tech tip videos, be sure to subscribe. In the meantime, check out our training website, training.diesellaptops.com, to see our full class list offering as well as locations and available dates. I hope to see you soon.